Good afternoon, I'm Roberta Rostellato and I'm going to present our study concerning the identification of longevity predictors in French dairy cattle. Dairy cows are mainly replaced for low milk production, that is the voluntary culling, or for other reasons than production, such as fertility problems or diseases. In this case, we have the involuntary culling. As consequence, two different longevity traits can be defined, the true and the functional longevity. The first one is the ability to delay any culling, whereas the functional longevity is the aptitude to avoid involuntary culling. The identification of longevity predictors is important, firstly because longevity needs a long time to be observed, but also because risk factors for culling can be proposed as a proxy to study and improve resilience. In fact, in the long term, resilient animals are able to maintain the normal processes when confronted with environmental perturbation. For example, they continue to grow and to reproduce successfully. It reduces the risk to be culled and they postpone culling. So, the objective of the study was to investigate the influence of several traits on true and functional longevity in order to identify risk factors for culling. The investigated traits were the insemination status, the calving ease, 9 type traits, the clinical mastitis, the somatic cell count, the displaced abomasum, and the milk fever. Data were from the French National Database for Bovine Selection, and regarding to data about diseases, they were from the sanitary diaries collected during the project GenOSanté. The study focused on French Holstein breed. We selected the herds with exhaustive records of health events in the herd over at least 5 consecutive years. We call this period of completeness of disease recording, CDR. And we consider the animals in the selected herds and with milk production records for at least the first lactation during the CDR period. After the editing, the dataset included almost 122,000 cows reared in 640 herds. The statistical methodology we chose for the study was the survival analysis. One of the main advantages of this methodology is that it allows to combine the information from both death and animals still alive at the end of the investigated period. In our case, it is from January 2007 and September 2018. So, there were two groups of animals, the uncensored cows, so the animals dead or that left the herd for disposal, and the censored cows. They were the animals still alive at the end of the period, the cows with more than 5 lactations, the cows that moved to another herd, and the animals with lactation length greater than 800 days. In our data, 49% of the cows were censored. The survival analysis was performed using the software survival kit. The longevity was defined as the length of the productive life, that is the time between the date of the first calving and the date of culling. To estimate the risk to be culled for each the investigated traits, we use the Weibull proportional hazard models. Firstly, we analyzed 2 base models. The base model for the true longevity included a part representing the Weibull baseline hazard functions for the 4 lactation stages and the 5 parities. And then the random effect of herd here, the fixed effect of age at the first calving, and the time-dependent fixed effects of herd size variation and calving year season. The base model for the functional longevity was as the previous one, but it included also the effect of milk production traits. In fact, there is no direct measure for the functional longevity, but we can obtain it by correcting the probability to be culled for milk production. After that, each effect related to reproduction, morphology, and health status was added to the 2 base models and tested distinctly from the others. The traits that show a measured effect on true and functional longevity were the insemination status, the calving ease, the udder depth, the clinical mastitis, the somatic cell count, and the displaced abomasum. Now I will present the results for one trait for each group as example. I start with the calving ease. The trait was classified in 4 classes based on the degree of assistance needed during calving, and it was studied in interaction with the parity, heifers and multiparous cows. The class including animals with unassisted calvings was chosen as the reference class. The graph shows that both heifers and multiparous cows had a higher risk to be culled after a calving needed assistance with respect to animals with unassisted calving. And the risk to be culled increased when calving difficulties increased. In addition, relative risk for functional longevity were lower than for true longevity. It suggests that farmers are more prone to cull cows that after a difficult calving are not able to maintain a good milk production. The type trait that showed the strong influence on true and functional longevity was the udder depth. Cows with deep udder had a higher risk to be culled than for animals in the reference class, that is the class 5. In contrast, cows having shallow udder had a lower risk to be culled with respect to the reference class. In addition, cows with low scores for the trait showed smaller relative risk for true longevity than for functional longevity. For animals with shallow udder, it is the opposite. Given that the udder depth score is somewhat corrected for production by the farmer when the culling decision is taken, probably a very deep udder is more unsettable if the cow is not a good producer. But a shallow udder is even more favored for high-producing cows. Now I present the results for clinical mastitis. The trait was classified in 5 classes, and the class 0, including animals without the disease during a given lactation, was chosen as the reference class. The risk to be culled increased as the number of clinical mastitis events increased. We can see, for example, that animals with 4 or more events of clinical mastitis had more than twice the risk to be culled with respect to cows that did not experience the disease. In addition, relative risk of culling were larger for true longevity than for functional longevity, except for animals in class 4. It suggests that for those animals, farmers prefer to keep the most productive cows, even if they are more prone to develop the disease. So, in conclusion, the insemination status, the calving is the other step, the clinical mastitis, the somatic cell count, and the displaced abomasum have significant relationship with true and functional longevity. So they can be used as a predictors of longevity. In addition, the risk factors for culling identified in the study can be proposed to study resilience in dairy cattle. And the differences in relative risk between true and functional longevity show that milk production often influences culling decision. Finally, I would like to thank the GenTORE project for funding the study and my postdoc fellowship, and the Genosante Consortium for providing the data related to diseases used in this study. And you for your attention.